I'm John Schrott, and this is On the Spot with IKM. Today we're going to be talking to one of our architects who really delves into the details and the importance of exterior wall design. A lot of you might not be thinking of architecture as exterior wall design, but part of our ethical responsibility is to keep water and wind out of the building. So, Larry, why is exterior walls your passion?
Well, I think it has to do with a multitude of different components that go into design. Wall sections, plans, all that with the exterior envelope is sort of a overall encompassing of any kind of building that we do. I think exterior envelopes is basically the shell that protects us when we're in the building. It keeps the thermal comfort as well as keeping water and wind, like you spoke about, out.
And it's kind of evolved over time, right? I mean, hasn't technology made exterior wall assemblies very different than what it was 25, 30 years ago?
That's very true. There's codes and regulations that are getting tighter and more stringent. There's U and R values that are becoming more important as we progress. There's new technology in regards to new materials and new methods of exterior envelopes. So all that goes into how the occupants within the building feel and how they use the building.
So there's a thing now called a rain screen, right? Explain exactly what a rain screen is.
So a rain screen is designed to allow water. It anticipates water coming into the cavity of the wall. But in regards to a rain screen, it provides a sort of a drainage plane that if any water does get past sort of the exterior shell of the building and sort of that cavity that wall section has, it's allowed to drain out and ventilate. As you spoke about, water is one of the major problems that we have with a lot of buildings these days. And any way that we can allow water to escape that wall section, that envelope, and allow the air to move and dry out that system, the better we are. Where just like any kind of ponding on the roof, any water that sits within that cavity has potential to find the least resistance. And usually it's with wind pressure and just finding those gaps in the wall where they could infiltrate and get into the building.
And you had spoke a few minutes ago about code issues because, as we continue to try and build more sustainably and use less energy, are buildings getting tighter?
Yes, they are, and that provides a problem that a lot of the architects and engineers see these days. Before traditional sort of older methods, the buildings weren't as tight, so they were allowed to breathe a little bit. Now, because they're becoming tighter and more efficient, it puts more stress on the mechanical system to allow makeup air from the outside to sort of mix in. Because in most buildings, we have to draw some natural, air from the outside in to mix with the conditioned space. So it does put a stress on the mechanical system. But again, with working with our engineers and designing the exterior system, we've come to develop a balance to get those comfort levels for those occupants to use the space.
And then one other question, the issue of dew point,
Yes.
right? Because that has changed over the years about where you want that really to be, right?
Yes. So the dew point usually happens when moisture in the air condensates. And usually that condensation happens when the humidity and temperature affects that moisture in that air. And usually happens within that sort of insulation that we have on our exterior envelope. So it's moved depending on the region and sort of temperatures that you get. Usually we want to try to keep the air and vapor barrier, sort of the membrane that keeps that moisture out. Usually we want to keep that on the warm side of the insulation. There's different methods on continuous insulation, which is another sort of methodology that we want to keep in our design of our exterior, because when we have insulation that's not continuous, we have those gaps. And when those gaps happen, does moisture and humidity come in, and that's when you start collecting those issues with water.
Well, I think I could talk to you for hours about this subject, but that's all the time we have. So until next time, this is On the Spot.